Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello and welcome to GOTO Book Club. I'm Duncan McGregor, and today I'm delighted to be interviewing Uberto Barbini about his book, From Objects to Functions, Build Your Software Faster and Safer with Functional Programming and Kotlin. It's published by Pragmatic Programs in September. Uberto, welcome to GOTO Book Club.
Hi, nice to be here, Duncan.
So, Uberto, we worked in the same circles in London. You were technical reviewer on the book that I wrote with Nat Price, and then I returned the favor by being a technical reviewer on your book, but we've never actually worked together. So how did you come to be working on Kotlin projects in London and now in Japan?
I was working in banks in London, and actually I started learning about the Kotlin many years ago when it was just before version 1. At that time, there was also another programming language in JVM that seems more promising, but after a few years, Kotlin really grew up on me, and I started using in the banks. And then I started looking basically at the beginning, we were using Kotlin, introducing slowly, creeping to write a test, to write a little tools. And then I started looking for a gig that I could write Kotlin all the time. And I think more or less we got in touch around that time. London Kotlin community, backend the Kotlin community is not that big.
So what prompted you to write the book? Who's it for?
Yeah, the idea of the book is basically, I'm very passionate about functional programming, but also about writing good code, with the good practice. And I didn't find much content outside about how to put together the two things. So all the books about TDD or clean programming or stuff like that tends to be very object oriented, and all the book about functional programming tends to be quite very specific exercise on specific things on functional programming. There was no book about how to set up a full project from scratch and adopting functional programming with the kind of a pragmatical point of view, let's say. So I think it's quite useful both for people that came from a Java background or also Kotlin, but use a bit of Java, Agile, simple Java. And they wanted to touch a bit of functional programming. Or people coming from more functional advanced stuff like Haskell or Scala and wanted to use, take advantage of Kotlin simplicity and productivity.
I should say it's the book isn't a sort of academic book. It takes a project. The example is a sort of to-do list, if I remember. And it takes us from sort of inception, the initial sort of prototyping, all the way through to a sort of complete database-backed application with a web front end and so on. And I found that was quite refreshing. It's not just how do you it's not just these are bits of functional programming. It is how to plug the functional programming into an entire project lifecycle.
Yeah, actually, we have a lot of beta reader for this book, and most of them really appreciated that. some people were a bit, let's say, not pissed off, but a bit disappointed that there was not much theory or more drilling down specific, super specific functional programming thing. But I kind of stand my position because I think it's not functional programming for the sake of doing functional programming. I mean, the point is to deliver an application at the end in our job. We wanted to deliver value to the user. So I'm trying to say, come on, with functional programming, we can be more productive, at least for a kind of applications like backends. Where so this is something that I did, and I think sharing it can be useful for other people. It's not about let's learn how to use 25 kind of monads or stuff like that.
So Kotlin's a sort of multi-paradigm language. I think Scala took that mantle first, but we can write procedural, we can write object-oriented or functional style. I mean, Kotlin sort of probably starts from OO, being on the JVM. Lots of the sort of libraries we use are object-oriented. But how would you look at some Kotlin code and decide that it was functional versus OO? What characterizes functional programming for you?
Yeah, I mean, the first thing is that it's really not that important that is functional programming object-oriented, but I appreciated that the advantage of a functional programming is having functions. Basically, everything is designed using functions and putting the function together to do some feature. I mean, to do some task. And the good thing is that combining this function, each function does just a bit piece of work and is very clearly defined from the input to the output. So it's easy to test. It's easy to reuse in another place if you have to do exactly the same things. And then you put together and you have a functionality. So when instead the code started to reference to external things like singleton or external calls without being clearly specified by the type system, then it became also very hard to use. I mean, I remember someone that actually in the banks at some point, someone was doing some calculation and got a function from another piece of the program. But that function was logging a lot of stuff, and just using that function slowed down the whole application, and we realized in production. So this kind of stuff, it's kind of easier with functional programming to see what you are actually doing without the kind of trusting the code.
So I mean, my experience of good OO is that it sort of shares those same sort of properties. Do you think there's still a place for object-oriented programming, or do you think we should look at all problems as functional?
No. I mean, I think actually this is a great thing about Kotlin, that you can use both, because a lot of class of problems are actually much easier to do in functional programming. Or also, if we wanted to break the rule, let's say, and have an internal cache or stuff like that, so far that is clearly defined. And it's very convenient. I mean, it's very productive. I can just do this stuff without keeping the code clean and having this stuff done. Plus, all this kind of problem that require kind of simulation, where you keep a lot of object with an internal state that are alive for a long time. They actually much better fit for object-oriented programming than functional programming. Is great when you have a kind of flow of transformation. So it fits more naturally web server or ETL application that just read from a message queue and write it to another message queue. This kind of stuff, which is quite common in the banks and other kind of big backend. It's really great, I think.
Certainly that's something I've sort of come to realize, I suppose only really recently, that the object-oriented programming I learned was about in-memory user interfaces where everything about the system was in one place. We could manage state in our memory. Whereas these days we just don't have those. We don't program like that anymore. Everything is thrown away between requests. Nothing stays in memory. We assume that our state is all going to be held somewhere outside of our program. So do you think that functional programming has sort of risen with web scale things? And that
I think, for this kind of, cloud, what is a cloud native, or however you want to call it, this kind of application where basically you just, process, the request to, responses, and everything is the state that you keep the state outside the application. So you wanted to have a kind of type security around the state to avoid to make to have a runtime errors or stuff like that because the connection was not open or something like that. All this stuff it came very natural. Very natural fit with the functional programming. I think in your book you mentioned walking along the grain of the language, and in this sense, it's also walking along the grain of the application. You need to do something like that in a kind of cloud native distributed stuff. Functional programming is a very good approach, in my opinion.
I think I've come to the conclusion that we have we're really still using OO, but the objects that we have are servers now. And that we're using message passing, polymorphism, all those sort of things to implement OO between things, and then functional programming inside those applications.
Yeah, that's definitely a way to see. The actual service work in a kind of external, from an architectural point of view, they work a bit of a object. And also, this is a bit what we are doing a bit of philosophy or history of computing, but Alan Kay came with this idea that basically objects are a bit like a computer on the net, something like that, and which is not super helpful. It's not super performance-wise a great idea to implement everything like that. But when you have the stuff that actually is on the net, it's very good.
So I think Alan Kay also said something about that the things that Java and I suppose Kotlin do in terms of OO is not object-oriented programming; it's class-based programming.
So that
one of the things that I struggle with in functional programming is that we learned in OO that encapsulation was a thing, that having classes and having data and the operation on those classes together was an important thing. Functional programming says no, actually they should be separate. Where do you sit on that spectrum? When do we decide? How do we decide?
Yeah, we in our team we have the kind of thumb rule that to decide when to use a lambda or an interface, just to maybe it's clear to you, but just to clarify, they say that you have a function that needed to access a database, and so you need your function that write something, and you pass another function that accesses the database and get the user. And then in some other point, you need a function to write the user to a database. Now, the general object-oriented approach will be to define a kind of interface of the database layer or stuff like that, where you put all this stuff together. And it's fine. I don't have anything, but if I needed to pass this data access object every time I needed to access the database, I made to pass really too much, because if I just needed to get the user, I'm passing an interface with 10 methods or 20 methods that I really don't need. So in that case, just passing a single function is an advantage. It creates less coupling. Our rule of thumb is that if you need one, is okay. If you need the 2 lambda, is okay. But if you need the 3 lambda from the same kind of interface, just pass the interface. Something like that.
I think that's probably the rule of thumb we came up with in the book as well. That yes, that there is. If you have to express a coupling on reading and writing, then you should probably have an interface. But if it's just reading or writing, then just one thing. Yeah.
That's another. And but that's actually another great thing about Kotlin, that they allow you first to leverage on the whole Java world libraries that are huge, and then you can kind of take the Java library and just pass the method lambda reference without having. In Scala you need to do Scala enclosure. You need to do a lot of things to be able to interact with Java. Is not that easy.
So, your book has Kotlin in the subtitle, but I don't think would you call it a Kotlin book?
It's definitely, it's a Kotlin book. You needed to read the Kotlin in the book, but I think the kind of teaching or the approach, let's say, is not specific to Kotlin. Actually, a couple of beta readers don't use Kotlin as a main language, and one learned Kotlin just reading the book, and they are using TypeScript mostly. And they said that they can make a lot of sense also this approach for TypeScript application as well.
Certainly, it's my experience that Java developers and TypeScript developers come to Kotlin quite easily. There are sort of changes in syntax, but lots of the sort of fundamentals are there. It's an easy language to read, and it's quite an easy language to write.
Yeah, no, definitely.
Could you have written the book in a different language?
Why not?
How would it have changed if you'd written it in a different language, I suppose?
Yeah, there are a few Kotlin specific things. Things that make some more sense. And I had to work in Java project recently, to be honest, and it's kind of painful to use functional style in Java because everything became a bit more harder. And harder. So you tended to write less functional stuff because the type declaration are very long. To do some transformation in a collection, you need to use a stream. Everything is more verbose, and it came so. And on the other side, Java programmer, when they switched to Kotlin, tended to keep the same Java approach before learning kind of Kotlin idiomatic way. But the main point, writing this application, I think if I had to write in TypeScript or some other language with a bit of functional capabilities, it won't be that different.
I think it's trendy to say that the language doesn't matter, but I do find that the things that a language makes hard, we don't do. I had a comment on one of my
videos
make recently.
Sense.
Yeah. Somebody was saying it was a video on property-based testing, and somebody was saying, "Oh, you introduced a type here in a way that I don't think that a Java programmer would, because introducing a type would have been too painful. But because in Kotlin it's sort of like 3 lines to introduce a type, then it's very natural I find in the language to solve problems with types. It's a natural language to solve problems with the things that are easy to do in the language."
Yeah, definitely. In Java, just the fact that you needed to create a new file kind of stop you. Do you really? Even if the file is just 2 lines, it's a bit different if you just put the temporary. Yeah, it's not.
So I was an object-oriented developer in the 90s, and I had the definition of polymorphism off pat. It was required in job interviews at the time. But your book talks a lot about thinking in morphisms. What do you mean by that?
Okay. Basically, for me, the kind of breakthrough of functional programming is is when I started realizing that data is not that important. What is more important is data transformation. So looking at the programming, like the design of the application, like a chain of transformation instead of a flow of data, let's say. And this transformation, I mean, in category theory, the most general way to call a transformation, is called a morphism in mathematics. And so I think, this idea of thinking in morphism, how you transform, without even looking at the code first, but just start looking at a web server as a machine that transforms requests in responses. And then for each possible part, you see, here I'm transforming a user ID in a user content web page. And every step is at the end is transformation. And there is this theorem in category theory, which is called Ioni dilemma, which mostly say, I'm paraphrasing, but that if you know all the function from a data type and to the data type, you can identify univocally the data type. So this idea that the connection are actually more important than the data shape itself.
Yes, I've heard it said that a type is not actually the data; it's the operations on that data is the thing that actually defines the type for us.
Yeah, I mean, the type is the shape of the data, but it kind of get uniquely defined by the relation that it has with the other data, basically.
I'm interested in your background. We didn't hear your education. Where did you learn category theory? How has this come to be?
Right now, I mean, it's totally self-learned. And I'm not definitely an expert, but I mean, expert for a time. I always been, to be honest, interested in mathematics, and I didn't finish the university, but I mean, I was studying. And definitely, category theory is very mathematical. And I also, to be completely honest, I don't think it's really needed to I mean, if you like, I think it's really great. I got a lot of fun and insights, but you definitely don't need to learn category theory to use functional programming. It's a bit like you don't need to speak Japanese to prepare sushi or stuff, or to appreciate the sushi.
Can you give an example where thinking in morphisms leads to better software?
Yeah, I mean, for me, it's a bit like when we approach a problem, just we needed to do this typically this new API to connect this other two systems to get some result and give the result to the user. This is kind of typical. And instead of, start drawing squares and arrows like this, trying to, for me, it's a bit of what is our input and what is our output? To try to identify the transformation and then say, okay, this is the main transformation. So we have, a financial product and the output is some kind of price or fair value. And, how we get from here to there. And there are a lot of possible possible way to do this using the system and trying to concentrate on this kind of flow, let's say. And this for me, I mean, thinking in this way, thinking about all transformation, how to put the transformation together, rather than trying to think about, I create a service A, a service B, service A call to service B, It's bit. I mean, the result may be similar, but the mental process for me is very different.
I wonder whether that's a place where AI can help us. That we that if, as you say, effectively you're thinking of the type signatures of this transformation, and we know we've got, like, I've got this ID for this thing and this way of trading this ID for this piece of information. I need this piece of information to find this. That maybe AIs would be good at plugging together those sort of pipelines.
Yeah, definitely. I mean, in a sense, I don't know, maybe just me, but I always find, I mean, you said that you started object-oriented in 90s. I was starting programming in 90s, and I think I got object-oriented around 2005. So after 10 years that I was trying to do that. And object-oriented for me has been always a kind of, poetic. Is a bit like literature. You need to very, to get something that work together. It's a bit hard. Instead, functional programming is more mathematical. So it's probably something easier for AI to plug together and verify that is.
So on that subject, I mean, yes, OO has a sort of, not mystique, but it has a sensibility, a sort of like, there is this idea of smells and this idea that this is the system that wants to come out of this problem, isn't there? So I've heard it said that we don't need patterns in functional programming, because patterns were sort of OO's, way of collecting things that didn't smell, ways of collecting nice shapes of things. And there was a lot of talk early, at least, that patterns were working around the lack of functional paradigms in the languages. But it seems to me there are lots of places in functional programming where we have to learn these reusable solutions to problems. I recently I think from your book, I read about the reader monad, and that finally sort of clicked for me what problem the reader monad was solving. But is the reader monad a pattern in functional programming?
I think wary of using the monad word, because I have a lot of weird. I mean, some people is saying monads. No. Some people say yes, monads, only monads, which are both wrong approach. And the point is that the monads are a mathematical construct. How you translate that mathematical construct in code is not a given. I mean, there could be several ways that you can do that. And of course, everybody tends to use the kind of there are a few variations, but mostly the same approach. But it's still just one possible approach. And I think this kind of approach is a pattern. I mean, the monad itself is a kind of a mathematical concept that sometimes, I mean, stuff that has been called monads are not much more monads. I mean, no programming monads is really 100% a mathematical monads. But some are probably not even 10%. They just use monads.
The same, of course, is true of patterns, that we learn patterns, but then the thing we call that pattern is not necessarily all of the pattern as it's defined, and so on. And we kind of stitch these things together, don't we? They are we build software out of things that play this part in this pattern, or this part in this this other pattern.
I remember when the pattern book came out, and people were at that time writing stuff like this is a visitor pattern class or abstract factory, and you put the name of the pattern in the class, and then the class maybe changes. So at the end, it became super confusing and stuff like that. So I really tend now not to use any monads name in my classes. Just use the monads pattern if you want. The idea that basically it's just a generic that you can transform, basically, and you can combine with other generic. And this idea, the transformation really makes a lot of sense to me. And also, kind of mark when you have something, if you have a generics around database connection or transaction, that function will be called in a context. It came quite naturally. I mean, it's also a good point to mark. Yeah,
it seems to me that pattern names in the names of types was an anti-pattern, but they were useful for documenting what role this thing had. So it was good for documentation, good for comments, but not so good for the names of things. And I guess that's probably true of functional patterns, readers, writers, and so on.
Yeah, it makes sense if the other people knows about, you can communicate very quickly. But if the rest of the team is not familiar, it's just confusing. And
so on the subject of the rest of the team, I think your book took me a lot about how, what should I say, real functional programmers think about solving problems, and how to evolve that software as we ask for new features. But how would you go about evolving software and a team from objects to functions?
I think the important thing is that to keep the team together. So not writing any code that the team is not comfortable with. On the other side, I think it's a good idea to keep a bit of a hit on. So always trying to introduce a new concept and stuff like that. In my previous team, I mean, same company, but the previous, we were basically two people of us was coming from this kind of functional culture. And we introduced the idea to the rest of the team about using result to do the operation and stuff like that. And the rest of the team was a bit like, well, this is definitely different from using exception or how we are using, but let's have a try. And they actually enjoyed. And then, the whole project switched very quickly from one to another paradigm. But I mean, I've been in other team where the feeling was really no. We always did it like that. This is not what we are going to do. But that's also fine.
So in the preface, you say functional programming makes my job more pleasant every day, even if it drives me crazy sometimes. I think your book does a good job of showing the ways in which it can make software more pleasant, but what ways does functional programming drive you crazy?
Well, sometimes, I mean, I really enjoy, really like having fun about, kind of solving the problem in this, using the type system. So using a transformation. So, okay, I can do this with a side effect, but if I can make this explicit to the type system using maybe C class or some kind of stuff like that, it's better. So this is the stuff that I really enjoy to do that, and I think the final code is less bug prone, but sometimes it's very hard, or you sometimes you say, okay, now let's go back because it's, but yes. Sometimes making the stuff compile is the most difficult part, and once it's compiled, you are quite sure that is correct.
Yes, I mean that balance of pragmatism versus correctness, I think, especially again as we were saying earlier, where what your language makes easy what your language makes easy defines pragmatism, I suppose. I mean, I know there are places where the Kotlin type system, there are things where you end up casting that you might in another language, the language might see that something was safe, for example. That's certainly my experience of Kotlin is that its pragmatism can lead to frustration sometimes, because we can't express something we want to in the same way as we might have problems with Java. making it harder to create new types than we'd like.
No, yeah, definitely. I mean, there was some stuff that I really like Kotlin make a bit easier to do, because there are some, for example, the companion object a bit underused in Kotlin, in my opinion, would be much better way to use that. And to expire some time would be nicer. But actually, yeah, this is true. But what they see that most of people, they really got scared from the beginning when they see the kind of code that I show at the end of the book, where basically everything is just a chain of, map, fold, and transformation, binding. And so every functionality is just in a single expression. And people got a bit scared about that. On the other side, I think, in the book there is this origami, because, in functional programming there is this fold function. But it's really that functional programming is a bit like origami. It seems much harder than it actually is. After a while, if you learn origami, it's not that big.
From what I know about origami, though, sometimes you have to start off with a lot bigger piece of paper than you think you might from the end result. The professional one, they really start with like 1 square meter piece of paper to do something. So I know the process of writing a book helped me to think about software. Did the book turn out as you sort of planned it at the beginning, or did it change your understanding as you wrote it?
Yeah, no, they changed a lot. Actually, I kind of rewrote it 2 or 3 times. Depending on a bit from the original idea was to have a book like this is the theory, this is the practice, and the editor told me, no, let's just be the practice, throw away the theory. And I think that was a very good suggestion. And then when we got to the beta readers, also I found that I was skipping a lot of, mental process and stuff like that. And when I started doing slowly and tried to put it down, I also realized that, maybe I can change things and make it more clearly. And when I finished the book, I realized that, okay, if I had to rewrite this book again, I would probably remove also a lot of not remove, but put the theory after. And I don't think you need that. I kind of passionate. I really enjoy to do mathematical stuff, but some people a bit got scared about that, and it's not really needed. But what you can always skip the part on the book.
I personally, I found the book sort of challenging, but it was enjoyable, and because it took us through, as I say, unlike most functional programming books, it took us through an actual example from the beginning to the end. There's motivation there in every step. So we are solving problems and looking at how those problems will be solved in a functional way, rather than just having them in the abstract. So we are motivated to read the theory. I think that worked very well for me.
Yeah, actually, the book is is writing a to-do application, which may be a to-do list, but actually it's quite a hard problem to solve, to write a good to-do list application. And the original idea was to do a kind of a more, Jira kind of software to ticket processing software. But I realized that just a to-do application is a lot of code to write and to make it, to explain the code, it really takes a lot of time.
And so finally, Uberto, do you have another book in you? Or is it too soon?
Too soon. I still have some blogs to write about this book, and think that I couldn't really put in the book. But I'm also my daughter has a 9-year-old, and I'm teaching her to do programming, but without pushing, but we do some session. And also to her classmate. And I really find it fascinating teaching programming to kids. And I don't know, sometimes I would like to write something about it or to put it together, the experience, because I really not very happy how they teach programming in courses and stuff like that. And instead, working with kids is so rewarding. But you need to raise the interest and let them explore. Programming is a creative activity. Most of the courses thinks that programming is like typing.
Uberto, thank you very much. Your book, it was published in September. Is there anything else you'd like to say about your book?
Yes, one thing that we didn't mention that in the book, I also put exercise at the end of each chapter. And these exercises are very useful to learn functional programming. But there is no solution in the book because of clearly a choice. But all the solutions are still available on my GitHub repository, and we will put the links here. So if you have the book and you want to see my solution, which is not given that are the best ones, you can always see in the GitHub repository.
Wonderful. So as Uberto says, that will be in the show notes, as will a link to his book, From Objects to Functions, Build Your Software Faster and Safer with Functional Programming Kotlin. Uberto, thank you very much. It's been a delight.
Thank you very much, Duncan.
Thanks for listening to this episode of the GoTo podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.